Okay, guys, let's look at your study guide that you had to do yesterday. Number 1 and 2 says the polygons in each pair are similar, which means they are the same shape but not the same size. Find the scale factor of the smaller figure to the larger figure. Now remember, with similar figures, we're dealing with dilations. So in a dilation, you got to remember this. If you are going from small to big, then your scale factor is going to be a number bigger than 1 or a number greater than 1. If you're going from a big image to a small image, which means you're getting smaller, your number is going to be somewhere in between 0 to 1, which means it's going to be a fraction or a decimal. So number 1, we're going from small to big. So that means that my scale factor has to be bigger than 1. So all I'm going to do is I'm going to take, it doesn't matter which way you go, and I'm going to show you why in just a second, but all you got to do is put a corresponding side. So I can put 10 over 15, and I'm going to reduce that by 5. That is 2 over 3. Now, is 2/3 bigger than 1? No, it is not. So that can't be our scale factor, because going from small to it getting bigger, it has to be bigger than 1. All you have to do is take this number here that you got and flip it. So your actual scale factor is 3 over 2. Now, if you would have went from big to small, the opposite of what this says, 15 over 10, that would have then given you the 3 over 2. Okay, so if it's supposed to be bigger than 1 and you get smaller, all you got to do is flip it to get the correct scale factor. So on number 2, again, we're going from small to larger. Okay, if you go from small to large and say you do 25 over 30, again, it doesn't matter which set of corresponding sides you do. I can reduce that by 5. That is 5 over 6. If I'm getting bigger, it has to be bigger than 1. So I know that all I'm going to need to do is flip it. And so my scale factor is actually 6 over 5. Because 6 over 5 is 1 1/5, which is bigger than 1. So don't forget that rule there for dilations that we talked about back in first 9 weeks. Numbers 3. State if the triangles are similar. If so, state how you know they are similar. So remember, they can be similar by either angle, angle, by side, 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 or by side, angle, side. Now don't forget, in proving similar, angles have to be congruent and sides are proportional. You got to show those proportions. Okay, so let's look at number 3. What do I know? First of all, if you look at this picture, I'm given 2 sets of sides. I am not given 3 sets of sides, so I can go ahead and rule out the side, side, side. I can pretty much rule out the angle, angle, because I only have 1 angle. So I'm going to mark that angle. That's A. Those vertical angles are congruent to each other. Do have 1 angle, and I have a side and a side, 2 sides that are right beside that angle. So I'm going to try to prove it by side, angle, side. In order to prove it by side, angle, side, I'm going to have to show that those sides are proportional. Okay, so I'm going to use side AC, which is 96, over, if it's hard to see from the picture, remember, go up to the letters up here. AC corresponds with AF. So AF is 12. Okay. And then if I were to go through and reduce that, All I have to do is type it into my calculator. 96 divided by 12 gives me 8. Now I've got to check the other set of corresponding sides. So I've got to go from whatever triangle I used on top. I have to use on top in the second ratio. So I use ABC here. So I'm going to use 80 over its corresponding side is 10. And 80 divided by 10 is 8. Sides are proportional. So these are congruent by side, angle, side. Number 4, if we just look at it, I know I can eliminate angle, angle. I know nothing about any of the angles, which means I can also eliminate side, angle, side. So we're working with side, side, side because I have 3 sides. Now, in order to use side, 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 we have to show the sides are proportional. So I'm going to set up a set of proportions. Let's use LM, 36. LM corresponds LM. First 2 corresponds to RS. RS is 60. So I'm going to take and I'm going to type this into my calculator. You can either simplify it and get a reduced fraction, or you can just type it into your calculator and see your decimal would be 0.6. Okay, now another side, MN, 24. Over MN is the last 2 letters, so it goes with ST, which is 40. And 24 divided by 40 is 0.6. Now, I can't stop there. I do have to check the third set of sides. So LN, 33. LN, first and last, goes with RT. RT is 55. So I'm going to plug that in. 33 divided by 55 is 0.6. So yes, these are similar by side, 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 because I've shown that they have the same ratio all the way through. Okay, looking at number 5, still doing the same thing. If we look, we have 3 sets of sides, so we're going to go straight to side, side, side. And again, I have to show that the sides are proportional. So let's just pick a side. Say UT is 28. UT, first 2 letters goes with BC. BC is 11. And on my calculator, 28 divided by 11 is about 2.54 repeating. So I got to show that all the way through. So TS would be maybe my next one. 49 TS corresponds with CD. CD is 21. 49 divided by 21 is 2.3 repeating. So right then and there, these are not the same numbers. So these are not similar. That's all you got to tell me. Not similar. Okay, number 6. If you look, I have no side links at all. They have not given me any side links, so I'm not using side, 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 and I'm not using side, angle, side. So I'm automatically going and thinking, okay, can I use angle, angle? So if I look, angle V and angle M are congruent. They're both 32 degrees. Here, I have a vertical angle, so those 2 angles are congruent. Therefore, I do have 2 sets of congruent angles. That's all that I need. So these 2 triangles are congruent by angle, angle. Number 7. Number 7, let's see. I can show that I do have 3 sets of sides. And I also have an angle. So this one could be proved maybe 2 different ways. But first we have to see if the sides are similar. Now you have to be very careful in this picture because you have triangle LKD here. And then you have triangle this triangle. Okay, so it's a little bigger. So you gotta be careful with what you're using in your ratios. So let's see. First of all, I need corresponding sides. So 14 here is going to correspond with this whole long side, which is 14 plus 7, which is 21. So 14 over 21 is 0.6 repeating. Now I can do 10 over 15. 10 over is 0.6 repeating. And now I can show LD is, if FL is 6 and the whole thing is 18, that means that LD is 12. So I can show this last set, 12 over the whole thing is 18. And 12 over 18 gives me 0.6 repeating. Now, in this one, you could use, I've just shown that all three sets of sides are proportional. So on this one, side, side, side works. But also, they do share this angle D. You could use side, angle, side. Either of those works on number 7. 8. No sides are given at all, so we can go ahead and eliminate side, 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 or side, angle, side. Throw them out. They gave me that angle E and angle M are congruent. And I also have a set of vertical angles here. Therefore, I have 2 sets of corresponding congruent angles. So these are similar by angle, angle. In this next set of problems, they tell you that the triangles are similar and they want you to solve for x. So in similar triangles, side lengths are proportional. So we're going to set up proportions to solve for my missing side lengths. So I'm going to take this side AC, which is 36, over AC corresponds with JC. JC is 9, equals, if I started in this triangle, I have to start in this triangle again, so 48. That's BC. BC goes with KC, which is negative 12 plus 2x. So again, we are going to cross multiply here. We're working with some big numbers. 36 times negative 12 is negative 432 plus 72x equals, multiply 48 times 9, 432. So I'm going to add this 432 over. We get 72x equals 864. Divide both sides by 72. And x equals 12. Okay, number 10. Again, if they're similar, sides are proportional. So I have triangle NVU here, the small triangle, and then NLM is the bigger triangle. So I'm going to set up a proportion. NV, 30. Over the side that corresponds is NL, that whole thing, which is 70. Equals, this short side is 27. Over this whole thing is 8x plus 7. So we are going to cross multiply. Get 240x plus 210 equals 27 times 70, 1,890. Subtract the 210 over, and 240x. So subtracted the 210 over, and I got 1,680. And then I'm going to divide that by 240. And I'm going to get that x equals 7.